We've been looking at linear equations and have seen that it's relatively easy to solve those by isolating the variable on one side, collecting the numbers on the other, and then you have the value for the solution of the variable. In this lesson, we're going to go back to quadratics, which we've looked at some, and review factoring those, and particularly factoring by grouping. Before we factor by grouping, it's also important to remember the concept of the greatest common factor, which is the largest number that will divide evenly to all the numbers or terms within a list of numbers. To find the GCF, these are the 4 steps that we follow. We have to find the prime factorization first. We list all the factors that each term has in common. So if only one has it, we don't list it. And then we raise each of those common factors to the smallest exponent. When we multiply all those together, we have the GCF. Let's perform that process for this list of numbers here. A cubed, 16a to the 4th, 20a squared. To find the prime factorization, I'm going to divide each of these. This I can divide into 4 times 2, which is 2 times 2 times 2, or 2 cubed. 16 I can divide into 4 times 4, or 2 times 2, 2 times 2, which is 2 to the 4th. And 20 I can divide into 5 times 4, or 5 and 2 times 2, so 5 to the 1st and 2 squared. Now remember, we're only going to list the things that they have in common. So our GCF is going to have a 2, and it's going to have an A. It's not going to have a 5. And then I'm going to list the smallest exponent for each. The smallest exponent for 2 is 2, and the smallest exponent for A is also 2. Because remember, if I use anything higher, they're not going to all have it in common. They have to all have it in common. So the GCF of these 3 terms is going to be 4a squared. That means they are all divisible by that. Once we find the GCF in all the terms in the polynomial, then we can divide each of the remaining terms by that greatest common factor to find the remaining polynomial factor. If the polynomial can be split, then sometimes we factor by grouping. So let's look at an example of factoring by grouping, and then we'll move into a complex example with a GCF. If I have something like xy plus 5x plus y plus 5. When I'm factoring, the first thing I'm always going to check for is a GCF. But notice that not all of these have an x, not all of them have a y, and not all of them have a 5. However, if I change my order here, I can rewrite this as xy plus y plus 5x plus 5, and that gets me things that they have in common. With these first terms, I can pull out a y, and then if I divide both terms by the GCF of these 2 terms only, I'm left with x plus 1. For the second set of terms, they both have a 5, and I can then divide those both by 5, and I'm left with x plus 1. Notice now that these terms have an x plus 1 in common. So I can pull out an x plus 1, and that leaves me with y plus 5. There's different ways to picture the factoring by grouping. If I rewrite the same problem and don't switch the order, notice the first 2 terms both have an x in common, which leaves me with y plus 5. The second 2 terms don't have anything in common except a 1, so I can think of that as y plus 5. Then I pull out what they do have in common now, which is the y plus 5, leaving me with the x plus 1, which are the same factors we already considered. Let's do one now where we have to pull out a GCF. If I'm given something like 10x squared y minus 25xy, I'm going to find the prime factorization of both terms. So I have 10x squared y and 25xy. 10 can be factored into 5 and 2, which is the prime factorization. 5 and 5 give me 25. So my common factors are they each have a 5. The lowest exponent is a 1. They each have an x, and they each have a y, each with the lowest exponent of 1. That means my GCF that I'm going to pull out is 5xy. I picture it as dividing each term by 5xy, which leaves me with 2x. Everything else cancels, minus 5. A great way to check these is you can always multiply it back out. So if I distribute here, I end up with 2x squared y minus 25xy, which is the original term that I started with.